Okay, welcome to chapter 1, section 2, linear equations in two variables. So a lot of this is going to be review. There may be some new stuff, but for the most part, it's just going to be a review of stuff that you already know how to do with linear equations. Okay, so what we're first going to talk about is slope, using slope. Slope is the steepness of a line. We know that that is in the equation itself, y equals mx plus b. The slope is the m. Okay, that slope is the rise over the run. So it's the change in y's over the change in x's. The actual slope formula we'll be talking about later is y2 minus y1 over x2 minus x1. Okay, so how do we use slope when we're graphing? Let's see, we have the slope-intercept form of a line here. We know that the b is the y-intercept. We actually used this a couple days ago when the example was we were supposed to plug in x's into a t-table and fill it out so that we could graph the linear equation. And we said, oh, let's just remember how we did it with y equals mx plus b. And it's so much easier to do it that way. Okay, so first of all, we have, all right, so our example 1, we have a few different equations we need to graph. So we'll graph this one in red and this one in blue and this one in green. Okay, so let's start with our red one. It's y equals 2x plus 1. So our m is 2 or 2 over 1 and our b is 1. So we always start with our y-intercept, and that's where it crosses the y-axis. So it crosses at 1. From there we have a slope of 2 over 1. So up 2 and over 1, and that would be my next point. I could keep going and keep going. I could go backwards. And that is line A. Okay, the next one is just y equals 2. So we are not, so we actually have y equals, it'd be like 0x plus 2. So 2 is our b, our y-intercept, and our slope is 0. So my y-intercept is 2, and I have a slope of 0. That means it goes straight across like this. It's a horizontal line. Okay, so if you have a y equals and then just a set number, it's a horizontal line. If you have an x equals some number, then it's a vertical line. Okay, then the last problem is x plus y equals 2. Well, that is not in the right form, so we have to do a little manipulating first. So let's subtract x from both sides and we get y equals negative x plus 2. Now we can see that our y-intercept is 2 and our slope is negative 1. So down 1 over 1, down 1 over 1, down 1 over 1, and then we have our line. Okay, so again, this is just a bunch of review from what you've done for the last several years. All right, so that brings us to the next problem, using slope as a ratio. Okay, so the maximum recommended slope of a wheelchair ramp is 1/12. A business is installing a wheelchair ramp that rises 22 inches over a horizontal length of 24 feet. Is the ramp steeper than recommended? Okay, so this 1/12 means that for every vertical 1 foot or 1 whatever, you have a horizontal 12 feet in order for this to not be too steep so that wheelchair would possibly have an accident. So we're going to set up a triangle as our base right here. So this is just, we're kind of using ratios, we're using proportions to see if this works. So I have 1, I know this is not to scale. So for 1 foot of vertical rise, it should have 12 feet of horizontal length in order to not be too steep, okay? The real situation, so we have this, a business is installing a wheelchair ramp that rises 22 inches. Over a horizontal length of 24 feet. The problem here is this is inches, this is feet. We need to know if this works out. So let's take the feet, 24 times 12. And we'll get a calculator here. This is 288 inches. Okay, so 1/12 divided out is approximately 0.083 repeating, and 22 over 288 is approximately 0.0763 repeating. So this is less than this. So then this would be an appropriate, this would work because it is smaller, less than, the slope is less than the recommended slope. So that's okay. It just can't be steeper. Okay, so then yes, this would work because it's smaller. Okay, so let's move on to the next situation using slope as a rate of change. So we have a kitchen appliance manufacturing company determines that the total cost in dollars of producing X units of a blender is C equals 25X plus 3,500. Describe the practical significance of the y-intercept and the slope of this line. Okay, so the cost is right here, the cost of producing X units of blenders. So we have a 25X plus 3,500. Now this is our slope. So we can think of that as 25 over 1. And since it's cost, we're going to call it $25 over 1. And our y-intercept is $3,500. So that means at 0 is 3,500, where 0 is the number of items. Or in this case, blenders, I guess. So at 0, if 0 blenders are produced, it costs $3,500. Now, how could it possibly be that it's going to cost $3,500 when no blenders are produced? That means this would be like the set operating costs. Like, for example, it would be like the cost to just buy the equipment. So 3,500 would be your cost to get started. And the $25 per X would be the cost of material per unit. So that's how you describe what those, what the y-intercept and the slope of the line actually stand for. All right, so that brings us to finding the slope of the line. And now we're moving into the formula. So we have the formula right here, slope formula. All right, remember it's the change in y's over the change in x's. So let's just go ahead and throw this one out there. We have 3, 4 and 5, 7. What's the slope of the line that passes through those 2 points? Well, if we name this x1, y1, and x2, y2, then we would take 7 minus 4 over 5 minus 3, which would be 3 over 2. Okay, so again, not something that is new and crazy, just a bunch of review. Okay, so again, find the slope of these lines. So we'll start with A. We're going to take 1 minus 0 over 3 minus negative 2, which gives us 1 over 5. So then we have letter B would be 2 minus 2 over 2 minus negative 1, which is 0 over 3, which is 0. And that is a legitimate slope. You can have a slope of 0. That's like a horizontal line. And then we have negative 1 minus 4 over 1 minus 0, which would be negative 5 over 1. So negative 5. And then we would have 1 minus 4 over 3 minus 3, which is negative 3 over 0, which is undefined. So whenever the denominator is 0, that's undefined. This refers to a vertical line, and that's why it has an undefined slope. Okay, so that was example 4. Now we're going to talk a little bit about example 5, writing linear equations in 2 variables. Okay, so you're familiar with your y equals mx plus b, but we also are going to be using the point slope form of a line, which is y minus y1 equals m parentheses x minus x1. And it's super easy to work with. So we're going to do this 2 ways. We're going to take this example 5, and I'll show you the way that you might have done it in Algebra 2 with Mr. Bruns. So y equals mx plus b. So this is our m. So we plug that in. This equation goes, we're given the slope and it goes through a point. So we're not given the y-intercept. So we have to find the y-intercept for this. So we plug in our slope, our m, and then we say, oh, well, okay, let's just use this, our x and y, to be plugged into the equation so that we can solve out for our b, because we don't know what our y-intercept is. So that's negative 2 equals 3 times 1 is 3 plus b, subtract 3 from both sides, and you get negative 5 equals b. So we found the b, but our actual equation is going to be y equals 3x minus 5. So that's our equation. Okay, so that's using the slope-intercept form of a line. But if you wanted to use the point slope form of a line, which I think is easier in this case, but if you're not used to it, then it's not easier. But the point slope form of a line looks like this. Well, our m is 3, our x1 is 1, and our y1 is negative 2. That's from this point right here. So y stays y. So we have y minus negative 2 equals 3 parentheses x, because x stays x, minus 1. So again, those came from here. I simplify this, I get y plus 2 equals 3x minus 3. Subtract 2 from both sides, and I get y equals 3x minus 5. Now in this case, either way is pretty much the same amount of work. If you have a situation where you get a bunch of yucky fractions, then it actually is easier to use this point slope form than the slope intercept form. But if you're most comfortable with that, it's fine. You can leave it that way. Okay, we're just going to do a word problem here. So this is the revenue per share for eBay Incorporated was 20 cents in 1998 and 91 cents in 1999. Using only this information, write a linear equation that gives the revenue per share in terms of the year, then predict the revenue per share for 2000. Okay, so here's what we know. We have a point right there. Now notice that our time should always be the x-axis. So this actually would look like this. Now, they actually told us from this that year 0 is going to be 1998. So I can take this point right here is the point for 1998. 1999, which is 1 year later, it was 91 cents. So this would be my 1999 point. So now I have 2 points. I can find the linear equation that represents this situation by using the slope formula. So that would be 0.91 minus 0.20 over 1 minus 0, which gives me 0.71 over 1. So my slope is 0.71. My B in this case is, remember this? My X was 0 in 1998, so that means my B for the year 1998 would be, or my Y value is also, my Y value is my B. So that is my equation. My equation is Y equals 0.71 X plus 0.20. So now what I could do is I could use this equation to predict any year going forward from there. So if 1998 was year 0, then year 2000 would be year 2. So I'm looking for an X value of 2. So I'm going to plug that in right here and solve this out, which 0.71 times 2 is 1.42 plus 0.20, and I get $1.62. And so that's how I can use that to predict. But that's how we make an equation out of this. Okay, now there may be another example, but I don't think I was going to do it with you guys right now. I guess I could. Equations of lines, these are all different ways to write the equations of a line. General form is like this. Vertical line, horizontal line, slope intercept, point slope, and then the 2 point, don't worry about that. We're not even gonna mess with that one. Okay, so the last thing I will cover with you is parallel and perpendicular lines. If you have 2 lines that are parallel, their slopes are equal. So if you know the slope of one line, you know the slope of the other. If you have perpendicular lines, their slopes are negative reciprocals. For example, if one has a slope of 1/3, then the other one has a slope of -3. You just flip it over and change the sign. We'll do a couple of these later. For right now, I think we'll close down, and this is all I have for you today.